engine. It works on second law, that entire heat cannot be converted into work, entire work cannot be converted into heat. From reservoir at high temperature T1, heat Q1 is extracted, which is supplied to working substance such as gas, which does work used for constructive purpose. Remaining heat is given to sink at lower temperature. T1 is greater than T2. Reservoir is at high temperature, sink is at low temperature. So Q1 plus work equals to Q2. So work will be Q2 minus Q1 in heat engine. Efficiency eta is work output upon heat extracted. This is always less than 1. Okay, just draw this block diagram and copy this.
Sir, Q1 minus W would be Q2, no? Q1 minus W would be Q2.
Q1 is Q2 plus W. Q1 minus Q2. Therefore, efficiency is Q1 minus Q2 upon Q1. So it is 1 minus Q2 upon Q1. Or efficiency is 1 minus Q2 upon. Done? Yes, completed full?
Yes.
Refrigerator means from sink, it extracts the heat. And then gas is compressed by doing work on it. And then excess heat is given to reservoir. अपना radiator जो होता है वो. In this case, work plus Q2 is becoming Q1. Therefore, work is Q1 minus Q2. Same पहले जैसा ही आया. But its working is given by coefficient of performance, which can be written as alpha equals to heat extracted Q2 upon work. It is ulta, not work upon heat, but heat extracted upon work. That is Q2 upon Q1 minus Q2. So alpha will become 1 upon Q1 by Q2 minus 1. I have divided numerator denominator by Q2. Or alpha is 1 upon P1 P2 minus 1. Alpha is always greater than 1. Right. Done? Bro?
Yes, sir.
Now we'll come out with our numericals. Open heat wala sheet. Last class is completed till 14th we have done last class.
Yes, sir.
PV diagram represents three processes. Represents three processes. Initial, this is 2V, this is V, third, first, second. A PV diagram represents three special processes for ideal gas equation. If Q1, Q2 are heat transferred, in this case, what is relation between Q1, Q2, Q3? Area under graph of PV diagram is work done. In which case work done is 0. The initial final position all are same from one temperature to second temperature. So du is constant in all cases because initial final does not depends upon path. It depends upon the start and ending condition. So initial in on first, final on second graph. So du is constant. Can I say this much?
Yes, sir.
For process 1, work done W1 is greater than W2 and W3 is 0. I hope you followed this. For first one, area under graph ज़्यादा होएगा ना? Not followed.
Followed, sir.
Followed.
Now, what is our formula for Q1 or Q2 or Q3? It is du plus work done in first, du plus work done in second, du plus work done in third. Okay. So from this, can you get idea? Third is least because W3 is 0. And Q1 is maximum. Not followed.
Followed, sir.
Q1 is greater than Q2 and Q2 is greater than Q3. This is found.
Done, sir.
16. In a thermodynamic process with 2 moles of gas, 30 joule of heat is released. Released means plus or minus?
Minus.
Minus. Because it is lost, so minus. And 22 joule of work is done on the gas. On the gas means gas will contract. It will be minus 22 joule. If initial internal energy is 20, then find final internal energy. Only difficulty in this sum is plus minus. Heat given out minus. गैस के ऊपर काम किया मतलब गैस compress होएगा, volume कम negative. After this is very simple. This is heat supplied is du plus dw. So minus 30 is du minus 22. Minus 8 equals to du. Minus 8 is final minus initial. So minus 8 will be final minus 20. Minus 8 plus 20 is final. Therefore, final equals to 12. Joule. This answer. 12 joule, option B. Convention, any doubt?
No, sir.
No.
Okay, then proceed.
Done, sir. A fixed mass of gas undergoes change of pressure. We are a fixed mass of gas undergoes changes of pressure and volume as shown in figure. When gas is taken from state P to Q, that means this is initial state and this is final. When the gas is taken from this, by state PR to PQ. First it is taken from PR to PQ wala state. In that case, 8 joule of work heat is absorbed. It is absorbed means plus 8. And work done, 3 joule of work is done by 8. By it is plus 3. From this, I can find internal energy which is constant for both paths. So internal energy will be 8 minus 3 equal to 5. Now U1 and U2 is same, which is 5. Then for PS, PQ, one joule of work is done. In this case, what is heat? So heat Q2 is U2 plus work done. U2 is 5. 1 joule of work is done by the gas. So 1. So 6 joule of heat is absorbed. D option. See, only difficulty again, see, absorbed, released. Be careful. Released means negative, absorbed means positive. Fortunately here only numerically एक ही value match हो रहा था 6. So you will mark absolute obviously that answer. But plus 6 minus 6 then you have to be careful. So 17th we got answer as 6 Joule.
Done, sir.
18th. Take 2 minutes, you all work on it. 18th one. Yes, got any answer?
Sir, option B.
Option B. That is minus 30 you are getting.
Yes.
Okay, let us check. Anybody else got minus 30? In cyclic process shown in the figure, ideal gas is adiabatically taken from B to A. Adiabatically from B to A. Is 30 joules. Work done B to A is 30 joule. Since process is adiabatic, that means what heat is 0. Correct now?
Yes, sir.
So can I say B to A, then Q is U plus W, which will become 0 equals to U plus W. Therefore, W equals to U equals to minus of 30 joule. U is minus 30 joule. फिर बोला है, it is taken from A to B, heat is absorbed 20, change in internal energy in process A to B. Change in internal energy in A to G. Plus 30 आएगा. Because B to A and back A to B, net internal energy should be 0, na?
Yes, sir.
So internal energy from B to A is opposite of internal energy from A to B, correct na? Hello?
Yes, sir.
So it will become minus of minus 30, which will be plus 30. बिकॉज अगर बी से स्टार्ट किया ए पे गया और फिर से बी पे आया, नेट चेंज इज 0. तो आंसर इज +30 ऑप्शन सी. वो हीट का कुछ काम नहीं है.
इसमें जब B2A जाता है तो वर्क इज डन ऑन द गैस ना, तो वो -30 नहीं आएगा.
Which case you are telling?
B2A adiabatic वाला. They have said work is done on the gas, तो वो contra.
No. So see, it is clockwise ना.
Clockwise
में what is positive हो जाता है ना.
Done, sir.
एक सेकंड. What Ashlesha said is work is done on the gas they have given from B to A. So it is minus. Yeah, you are right, Ashlesha. Only for this part they have given, na? Not complete part. So B to A -30. That means you will be +30. Absolutely right. So दूसरा वाला उसका उल्टा -30. P is correct. You all were right. I am wrong. Because on the gas they have given. Now come to 19th. Ideal gas. Okay, take 2 minutes. I feel you all will be able to manage.
Sir, option C.
C, you are saying. Ideal gas is taken through the process as shown. Temperature is constant, pressure is increasing. So pressure increasing, temperature constant, P is directly proportional to V. So work done is positive. Work done positive. A is correct. Oh, sorry. P is increasing, V is decreasing. Work done is negative. C is correct. All of you got C? Hello?
Yes, sir.
See, because temperature is constant, then internal पे कुछ फर्क नहीं, neither increase nor decrease. So only option left out, work done. Pressure is increased, volume will decrease at constant temperature, therefore work done is negative. 20th. A gas at pressure of. This also I hope you can do.
Find the work done. Work done will be area under graph. Work done equals to area under graph. That means this whole thing is work done. Which is half of sum of parallel side into perpendicular distance between them. So these are two parallel sides. One is 6 and other is 4. And perpendicular distance between them is this, which will be 2. So 6 plus 4, 10 into 10 raised to 5 joule. That is nothing but 10 raised to 6 joule, option.
Done, sir.
Two samples AB of a gas have initial temperature compressed from V1 to V by 2. A isothermal and B adiabatic. The final pressure of A will be how many times B? So relation between pressure you want, first isothermal, then adiabatic. Volume is changing from V to V by 2. So for isothermal, we know pressure of P1 V1 equals to P2 V2 for isothermal. Right?
Yes, sir.
Both the gases are initially at same temperature and pressure. So P1 is P, volume is V. P2 I don't know. V2 is V by 2. That means P2 is 2 times P for A. First equation. P2 for A we got. Now for adiabatic process, you know that PV raised to gamma is constant. So it will be P raised to gamma, P of B in second case, V by 2 raised to gamma. So PV raised to gamma is PB in second case, V raised to gamma upon 2 raised to gamma. That means PB of second case is 2 raised to gamma of P. Now 2 is greater than 2 raised to gamma or 2 raised to gamma is greater? Who is greater? The power
2
is
raised to gamma.
so that means P A will be less than PV. This is the answer. Because this is greater. Pressure of A is greater, B is greater than that of A. So B option, it is less than that of A. Try 22 with that diagram. PT diagram is given. times the third. 22. An ideal gas changes the state from A to B as shown. Yet P is directly proportional to D. Therefore, B is constant. So work done is 0. Okay, yeah, sir. Okay. Aryan saying clear?
Yes, sir.
An ideal gas is taken from A to B to C and back to A. Back to A to B to C and back to A. So 1, 10 pressure is Newton per meter square. This is voltage meter raised to volume meter raised to 3. An ideal gas is taken from A to B, B to C, C to A, as shown in the figure. If net heat supplied to the gas is 5 joule, Q net is 5 joule, then work done by gas in the process from C to A. Okay. Net heat from C to A. What will be net change in internal energy? Net change in internal energy? 0, no? Because you are starting from A and coming back to A. This is initial, this is final. Net change in internal energy, is it 0?
Yes, sir.
So my Q net will be work done in AB plus work done in BC plus work done in CA. Okay? Not followed this line?
Followed, sir.
A to B, pressure is constant and volume is changing. So it is pressure 10, 2 minus 1. This is work done. P into dV. P is 10. Volume is 2 minus 1 changing from A to B. A to C. Volume is constant. So it is P2 minus P1, no change in volume. So 0. C to A you have to calculate. Done now. 5 equals to 20 plus work done from C to A minus 15 is work done from C to A. Check. We have this option. Minus 15. Yes, C option.
Done, sir.
Come to 24. In the figure 3, isothermal process is given. Because its initial final is on the same line. Final, initial, temperature is same. So change in internal energy is 0. Heat supplied is work done. ये डेल्टा V सबका सेम बोला है. और एक T हो गया. So it is clear cut. This area is maximum. So it will be Q1 greater than Q2 greater than Q2. Option. Fifth. The ratio of slope of PV graph of adiabatic. So slope of adiabatic to slope of isothermal U in PV diagram. Do you know what is slope of PV diagram? Can I say it will be dP upon dV? PV में slope क्या होगा? dP upon dV? Hello? For adiabatic, are you able to remember that slope is nothing but gamma into P? Because PV raised to gamma is constant. So dP upon dP, dV will become gamma P, which is called bulk modulus. Are you knowing this? Yes or no? Do you know that slope is gamma times P? And for isothermal process, slope is only P. Do you know this?
Yes, sir.
Now I'm telling this from sound chapter. So my ratio will become gamma is to 1. I'm explaining you how again. Answer I got. Gamma is to 1 means gamma. Now see how. I'm interested in dP upon dV. Some number clear to 27. For adiabatic, PV raised to gamma is constant. So it is P gamma V raised to gamma minus 1 into dV plus V raised to gamma into dP, constant will be 0. That means P gamma P gamma minus 1 dV is minus V raised to gamma dP. So this will be gamma P is minus V raised to gamma dP upon V raised to gamma power minus 4. So that will be gamma P equals to minus of V raised to gamma, this goes up, minus gamma plus 1 dP. So gamma P so gamma P equals to minus V into dP upon dV. So gamma P is minus of dP upon dV by V. इसको बोलते हैं बल्क मॉडुलस और वो रेशियो ऑफ स्लोप डिवाइड बाय V, रेशियो में कैंसिल हो जाएगा. और isothermal PV is constant. So PdV plus VdP is 0. Therefore, PdV is minus VdP. From this, P equals to minus V dP upon dV. So therefore, P is minus dP upon dV by V. Therefore, P is again bulk modulus only KVL. This is equation 2, equation 1. So in first case you got dP upon dV, gamma P ratio में cancel हो जाएगा. दूसरे में P. So gamma P upon P, answer is gamma is to 1. Followed now how I did? Hello?
Yes, sir.
Or as I said, yeah, I know that bulk modulus K is gamma P. In case of adiabatic, it is P. In case of isothermal, so if you take ratio of these two, so I will get slope here of adiabatic and that of isothermal, gamma is to 1. This is how I remember. So answer is gamma is to 1 or only gamma. 25th ka A.
Done, sir.
Next. 26. From the following PV diagram, select the correct statement. V1, V1, pressure V1, V2, pressures. They want relation between T1 and T2. This is V and this is V. Want relation between T1 and T2. Hello? Hello?
Yes.
So in first case, it is V1, V1. In second case, it is V2, V2. Here temperature is T1, T2. We want relation between T1 and T2. This is the question. T1, T2 for relation. Mx plus Y means this, pressure. Here mx. What will be m? Can you tell? What will be slope? Hello? What will be slope? I'm trying to find equation of this line. So my y coordinate is p, x coordinate is b. Mx plus c. C means y intercept. So y intercept means x is 0 you have to put. Then you will get c. Hello?
Yes, sir.
What will be slope? It is change in y coordinate upon change in x coordinate. So can I
Yes.
say P1 minus P2 is this distance, and this will be V2 minus P1. लेकिन उसका negative because it is उल्टा ना, obtuse angle. So minus of T1 minus T2 upon V2 minus V1 into V plus Y intercepts. That means P into V2 minus V1. This guy's calling it name. What is relation between T1 and T2? This negative T1 V1 upon T1 is always V2 V2 upon T2. This is always true. Hello? This is always true. For ideal gas, this is true.
Yes, sir.
T1 V1 upon T1 is always P2 V2 upon T2. That means T2 upon T1 will be P2 V2 upon T1 V1. P2 V2. P2 V2 is P1 V1. What is the relation between them? Between temperature T1 and T2. See, it is not isothermal, so I can't take T1 equal to T2. Please be careful. Hello? If this is isotherm, then graph is curved. Then I can say no T1 equal to T2. Hello?
Yes, sir.
Yes.
But this is this way graph, no? So don't think of that. T1 equals to that. We can take both equal. Now area under this graph, this much, will give what? Heat, na? Area under this much. Work done, it will give me. Area under this graph, this, what it give? It will give work, correct?
Yes, sir.
And area under this isotherm also gives me work.
Yes, sir.
So work in this case will be greater. In this case, first case, work will be greater. And in isotherm, work will be smaller. So work general here is greater than work in isotherm, because it is the graph which will cover less area. Now internal energy is same. In isotherm, what is internal energy? 0. So heat supplied in isotherm will be equals to work done in isotherm plus 0. And heat supplied in general is work done plus internal energy. Agreed?
Yes, sir.
Now this is 0. Isotherm mein work done, this U is 0. So if heat supplied in both case, I consider in isotherm heat will be less than that in general, because इसमें work plus internal दोनों है ना. Clear?
Yes, sir.
तो इसमें work done के साथ internal, so that means our internal is work minus heat, and here there is no internal. Work minus heat. Work is positive minus heat. Internal energy is work plus heat. Heat is greater. तो ये negative आ जाएगा ना, because heat is sum of the two. Hello? Hello?
Yes, sir.
ये थोड़ा कॉम्प्लिकेटेड है. अभी फाइनल अगर इंटरनल एनर्जी इज नेगेटिव चेंज तो फाइनल कम है ना, मतलब T2 इज लेस देन T1. ये आंसर है इसका. T2 लेस देन T1 और T1 ग्रेटर देन T2 एज इट इज. T1 greater than T2 we can write. 26th answer, T1 greater than T2. Because in isotherm condition, if I take second one, internal energy heat supplied is 0. But in second case, it is coming negative. Negative means T1 is greater than T2. Have you followed this wala case? ये PV वाला case? थोड़ा डाउट लग रहा है ना?
Yes, sir.
मैं और थोड़ा सोचता हूँ और कौन से मेथड्स आपको समझा सकता हूँ. एक तो मेथड क्या बोला मैंने, हीट वाला. हीट इज U plus W. आइसोथर्मल का U 0, दो हीट इज सेम एज W. लेकिन अगर आइसोथर्म कंडीशन लूंगा तो वर्क डन विल बिकम लेस. Okay, I will just keep this in bucket list to explain you. 27th I think we have done. No, 27th we have not done. But clear cut, as temperature increases, isotherm graph shifts upward. So T2 is greater than T1. This you are knowing? Isotherm shifts upward when temperature increases. This so I think you know.
Yes, sir.
So therefore, option will be T1 less than T2, that is T. 28 we have done. 29. In the indicator diagram, net amount of work done will be. Indicator diagram is clockwise, anti-clockwise first one, clockwise second. Clockwise circle is greater, na? Clockwise is greater, correct? Than anti-clockwise?
Yes.
Yes, sir.
So positive is greater than negative. So net will be positive. Net positive work done. Yes, answer is then A. Clockwise means positive, anti-clockwise is negative, clockwise bada, therefore net is positive. Except 26, I think all you all followed that.
Yes, sir.
Yes, sir.
If gas is expanded to double its volume, so new volume is double of origin by two different processes. One is isobaric. First is isobaric, constant pressure, and the other is isothermal, which is constant temperature. If work done is W1 and W2, what is relation? W1 is PdV, that is P into V2 minus V1, that is P into 2V1 minus V1, which you can write as P into V1. This is first work done. Second is isothermal. Relation of W1 and W2. So it is nRT log of V2 upon V1. That is nRT log of 2V upon V. Now nRT is nothing but P into original volume V. Okay, now log 2. Therefore, my W2 is W1 natural log of 2. A option. Yes, 30th clear, no?
Yes, sir.
Just after the class, I am sending that mechanical properties of fluid wala paper report. Fluid mechanics.
Done, sir.
Second law of thermodynamics states that no heat engine can be 100% efficient. That means entire work cannot be converted into heat, only they are proportional. But not work is equal to it. Consider following two statements and select the correct answer. If heat is added to the system, its temperature may always increase. Is it true? Heat added to the system, always temperature will increase. Heat is Q, U plus W. So Q is Q minus W.
Yes, sir.
If heat is added, then temperature must always increase. Barabar?
Not always.
Not always. Okay. So नीचे बोला है, if work done is positive, if positive work done by system, its volume will increase. ये तो बराबर है. Positive work means volume will increase. तो B तो बराबर है.
Yes, sir.
तो सेकंड वाला रॉन्ग इसलिए, अगर आइसोथर्मल हो गया तो U तो 0 होता है. So for isothermal, if you add the heat, entire heat is used for work done in that case. Correct or not? Hello?
Yes, sir.
So that means it is not always true. So A is wrong and B is correct option. Sum number 33. Not saturated now? Even Carnot engine cannot give 100% efficiency because we cannot reach to absolute zero. For 100% efficiency, we should get absolute zero temperature. What is formula for efficiency? T2 by T1?
Yes, sir.
So we cannot get zero because T2 cannot be absolutely zero every time. If we can reach to zero temperature, then only 1 minus 0 upon anything will become 0. Efficiency will become 100%. A option. If temperature of the sink is decreased, sink means this numerator. If numerator is decreased, then efficiency of engine will increase. Correct? कॉमन सेंस है ना. सिंक में जितना कम हीट जाएगा उतना कम टेम्परेचर, उतना एफिशिएंसी ज्यादा ना. So it will increase.
Yes, sir.
So today we stop here. Next 6 sum we'll do in next class, because I don't want you to have saturation limit and don't understand the sum. So except 26, rest all we have done. Means you have understood. Now after the lecture, I am sending the paper. Still there is 15 minutes as per our time schedule. You can complete that paper, so that immediately at a stretch your physics part is over for you. Shall I send it just now?
Yes, sir.
ठीक है, जिसको कंटाला रहा हो बाद में लिखना, but try to complete just now. Next class is on Monday. Time is same. We'll be starting after completion of this 4 sum, waves and oscillation. Once that chapter is over, then I will start with work power energy. After work power energy, gravitation. Then almost we have completed everything. And from May 15th to 22, we will solve. From May 15 to 22, we'll have daily lecture. Here extra practice we are going to do. From 2013, that is 15, 16, 17, 18, 19, 20, 21, 22 days are there. 13, 14, 15, 16, 17, 18, 19, 20. आपके पास पेपर इतना है ना, 2020 का 13 से लेके 20. Daily 1 paper will revise from 15 May to 22. So that's all for today. We'll meet in the next class on Monday. Just now I'm sending you the paper. Everything is clear about our program. Next, when we are meeting?
Yes, sir.
We are meeting on Monday. Topic will be waves and oscillation after completion of this few sums.